going to show the switch in 3 different ways in this video. First off, we're going to have the actual switch, the picture, and the schematic diagram. Now, our actual switch, most of these 3-way switches will come with the ground screw. In our diagrams, we won't show that. First off, the black screw is always called the common. Okay, so if you ever see a black screw, that will be the common screw. So there it is in the picture, and there it is on our actual switch. Next part is all 3-way switches will always have 2 brass screws. Those are travelers. Those help the switch talk to the other switch. So there's travelers on there and travelers on there. So here's how this demonstration is going to work. We have device box 1, device box 2, we have our light, and we have our AC power supply. That all corresponds with our schematic at the bottom. There's the AC power supply, there's our first switch, and our second switch. You'll see the rocker arms here and here. Those are going to depict the switch going up and down. So how a 3-way switch works now. When I turn one switch on, the rocker arm goes up, and the common now is attached to a different traveler. When I put the second switch up, again the rocker arm goes up, and it's attached to a different traveler. Okay, so the first thing that we're going to do in this video is we're going to attach the 2 wires. The first wire that we're putting in here in between the 2 boxes, you're going to need a 14-3. That's going to have 3 insulated conductors. You'll have a white neutral, and you'll have a red and a black insulated conductor, as well as there will be bare copper wire inside the NMD. NMD wire is kind of your most common wire. It's used behind drywall mostly, behind walls. It doesn't have a lot of protection. There's only a plastic jacket, so you have to be careful with this stuff. You're never supposed to see this exposed behind walls. And also, just for safety's sake, all boxes do need to be grounded. That's Canadian Electrical Code rules. That's called the bonding connector. So we're connecting the ground wire to the back of each box. We'll do that up quick before we move on with all the rest. It's always a good idea to hook up your grounds first, making sure that everything's safe. So now, as I said, on each switch, most of these 3-way switches that you buy are going to have a ground wire attached. If it doesn't, if it's an older switch, you don't need to connect the ground, but if it is provided, you do need to connect it. So, what I'm doing right now is I've cut a short little piece of wire from another source, and I'm going to hook all 3 wires together. So in the video, what you'll see is I've taken the green insulated conductor from our test wire, the bare copper wire from our 14-3, and I've added a pigtail. And you always got to twist those together and put them together with a wire cap. So the first thing we're going to actually do is we're going to run our wires. So first off, our NMD 9014-2 will run from the power source into the device box number 1, and we're going to need that 14-3 going into device box number 1 to device box number 2. The first thing that we will hook up is our hot to the common. So from the AC power source, the black wire will go to the common screw. Just finishing up with our ground on the switch, and we're going to hook up the common now. So on our test cable, this is a stranded cable, so normally we would use a spade connector on there, but it's just going to be a temporary connection here. So I'm just going to twist it with my fingers and hook it clockwise around that black common screw. Once you get it nice and hooked around there, make sure there's no cable or wire hanging below the switch. Tighten up really nice and tight. The next stage is to hook up our neutral wire. So we have our white wire coming from our 14-3, and we have our white wire inside of our box. This is what we're going to hook up next here. Okay, so we're going to use a Moret or a wire cap, Scotch lock, whatever you want to call it. It needs to be twisted, usually with line pliers. Make a nice double helix and screw that on clockwise. Give it a good tug, make sure that it hasn't popped off or that it won't pop off inside the box, and we now have a neutral. Really, the first rule in connecting a 3-way switch is the neutral wire needs to get to the light as fast as possible. So rule number 1, neutral goes to the light as fast as possible. So the next thing we're going to get to is we're now going to hook up the 2 travelers. So the black to one screw, to one of the brass screws, and the red to another screw. Now, the interesting thing about travelers is it doesn't matter which traveler they go to, as long as a traveler gets attached to another traveler. Okay, so let's flip the slide here. And we'll start hooking up those travelers. So there we are, we're hooking up the black to one of the brass screws. Stripping a little bit of wire, making sure you have about 2.5 centimeters, that's all you need. If you strip the wire too long, someone's going to hang over the switch, and that can cause a shock hazard or it'll create a spark. So now hooking up the red to the other side, making sure that we go around clockwise. Tighten that up, give it a good tug, again making sure that there's no exposed copper below the switch. Make sure those neutral wires are really well and tight, give them a tug. Make sure that wire cap's not going to fall off. And there you go, there's one done. We'll get this other one done in fast motion and move along here. So again, it doesn't matter where these travelers go. So the black and the red traveler just have to go to one of the other two screws. Last wire we're going to connect is our last NMD90 14.2. We only need 14.2 because all you need to the light is a hot and a neutral. So again, connecting the grounds, making sure that they are good and tight. You don't want those popping off. That's your first line of safety in this whole system. Now, make sure you tuck all these wires nicely to the back, especially this bare ground. There's lots of bare copper there. If it ever popped up and touched one of the screws, there's going to be fireworks, and that's no fun. No, I suppose it's fun to watch, but not when your house burns down. Anyways, we're going to connect the neutrals, making sure that we get a neutral to that light. Put the wire cap on. Hook up this last common wire. So the last one here on the switch here, we have to hook up the common wire. So that's the black screw, and that's going to go to the brass on our light. So for following the path of electricity here, it's coming through the power source into the common. If we go down to this one, it's going to go to our first traveler. In this case, it's hooked up through the red, then it's going down to the common and into the light. So let's finish this project off. Get that common hooked up. Tuck in those neutral wires. And hook up the keyless lamp holder. Now, the keyless lamp holder that we're using, it's really just a temporary solution. A lot of people have these in their basements, but they're really kind of junky looking. They're not very nice to look at. Here we are hooking them up. So our white wire, our neutral, goes to the silver screw. Now this is really important. The neutral, the silver screws are actually attached to the screw part on the keyless lamp holder. The brass part is attached to the back button right at the back. The light will light up if you mix these up, but it actually makes it quite dangerous, because if you're changing a light bulb and maybe you're getting lazy, you don't unhook the breaker at the box, or you don't turn off the switch. If you have these switched around and you start unscrewing the light, if you were to accidentally touch the screw part of the light bulb, you would take a shock. Okay, so it's really important that the black goes to the brass and the white goes to the silver. Just like we see in the diagram here. So black's to brass, neutral is going to go to the silver light there. Okay? Kind of the one invention that I'll give credit to Thomas Edison on this one. Again, making sure that our octagon box is grounded, tucking that to the back of the box again. The octagon box is substantially shallower than the other boxes, so you really want to make sure that ground wire is tucked in nicely so that it doesn't pop up and touch one of those screws on the keyless lamp holder. Last stage here is to tuck all the wires into the box. getting the neutrals down there. And you want to try to do this so it looks kind of pretty inside of the box. No one likes pulling out a nasty rat's nest of wires. So fold them all nicely, kind of fold them over top of each other, and push down the switches. Keyless lamp holder is an important one here. When you're getting the keyless lamp holder on the octagon box screws, don't over tighten them because the keyless lamp holder is made out of really junky plastic. It's going to snap. The last stage here is to get these screwed in. That's an 832 screw if you've ever lost one. Oh, sorry, not an 832, a 632 screw if you've ever lost them. So you can buy new 632 screws, and these little white ones, most often they come with the keyless with the switch covers. But if you do manage to lose one, you can get them off of Amazon. It's usually an add-on, but I always like to have some extra around. Lastly, with this, just because if you're into aesthetics, these use a slotted screwdriver, so I like to have the screws lined up either horizontally or vertically. But that's just a little bit of pettiness. You always want your work to look good. This is sort of one thing that people look at when they're in a house. They look at the switch covers. They don't see the stuff behind there, but you do want it to look nice. Better chance of you getting hired back. Now finally that we have it all together, let's see how the whole thing works. So right now, there's two main places that you'll find a three-way switch in a house. On the top and the bottom of the stairs, and on either ends of a hallway. So right now, if everything's live, our AC power source is on. Power's going through the black common, up through here, into one of our travelers, across the black wire, and into the other traveler, and it stops dead there, so our light is turned off. How I now turn the light on, let's say I want to go walk down the stairs. I go flip a switch up. Now the power's coming through the common, through a traveler, through another traveler, down into the common and to the light, and the light turns on. I get to the bottom of the stairs. I want to turn the light off. So I'll flip the switch again. At the bottom of the stairs, I flip the switch off. And now the AC power supply into the common, into the red wire, and it stops dead there. There's no connection of the circuit. Alright, and that's how a three-way switch works.